In the previous video, we looked at how to make vectors perpendicular. I actually forgot that I had this tool. I just wanted to show you that here we have this vector here, and ignore this shorter one here. We'll get to why that one's shorter in probably in the very near future. We have this vector here. It's 0.75, so 0.75, and then 1.25, 1.25. You can see I'm using the perpendicular tricks to get either my clockwise perpendicular vector or my counterclockwise perpendicular vector. And I can come up here and slide these around, and hopefully you're seeing or can be convinced that yes, this is looking very perpendicular, very 90-degree-ish. Alright, so again, you could go work out the math to prove to yourself that yes, this would always work. But I kind of like to see things visually. It helps me understand what's going on. So there you go. Let's actually go write some unit tests and implement this logic. We'll do this in the vector 3D test. I mean, what we're doing is a 2D thing, a two-dimensional thing, but we're using three-dimensional vectors. You may think, Jamie, how do I get a three-dimensional perpendicular vector? Well, that's a whole nother story for a whole nother video. We're going to stick with just the x and the y in this case. And remember, the whole reason we went 3D was so that we could do translations and affine transformations and that sort of thing. We'll go 3D-dimensional graphics in the graphics part of the engine development. Let's go down here and say test vector 3D. And you may think, Jamie, these tests are getting old and lame and short, and some of them don't. Like this one, we did the subtraction. It's kind of like, well, we made a first and second. If we subtract them, of course these are going to be the values. Why even write a unit test for that? Well, just because I'm picky. You can skip the video if necessary. Let's do perpendicularity. I don't even know if that's a word, but I'm going to say it. And since this is not Microsoft Word, then it won't give me a red squiggly on it. Maybe I should Google and see if that's a word. All right, let's do vector 3D me vector. And let's just give it some arbitrary coordinates here. 4 and 2 sounds good. And then let's say vector 3D perp clockwise gets me vector dot perp. Perp is short for perpendicular. And CW for clockwise. Maybe I should spell this out. Perpendicular clockwise, is that right? That's just kind of. Is this too terse? I hope that's not too terse. Perp clockwise, and then I forgot my semicolon. Vector 3D perp counterclockwise gets me vector dot perp counterclockwise, like so. But we need to be a little more specific on our function names because we're doing perpendicular vectors on the xy plane. Remember, we're using a three-dimensional vector here, a vector 3D. And if you can think of in three dimensions, if we had like a three-dimensional room, you're sitting in a three-dimensional room. If we put the origin at the center of the room and we ran a plane through the origin on all three axes, so one down the y, one down the x, and one down the z, we'd have like this, I don't know, these cards kind of cutting into each other. Anyway, we'd have multiple planes which we could make perpendicular vectors on. Well, we're just doing the xy plane. If you look at the screen here, remember in OpenGL, I'm saying this is the x and this is the y. You can picture z as a arrow coming out and pointing straight at your nose, or maybe it's pointing into the screen. We'll get into those kind of things later, but there's a z there. Well, the plane that we're messing with here, the plane we're playing on, is the xy plane. This is the xy plane. So I'm actually going to be a little more particular here and say perp CW xy plane. Is that? Let's just say perp CWXY. That might be too cryptic. I don't know. They may think, well, Jamie, we should do an XZ and a YZ, and yeah, we could, but we don't need to. And I'm programming on demand here. I'm not big into thinking into the future and saying, oh, well, I might need that, or I might need this. Let me add all this extra functionality just to take up my time. I'm trying to get stuff done here. All right, that's totally religious war. but that's my approach. I'm doing just-in-time coding. I know I need this test-driven development. Let's just roll with that. So mu vector, we have the perp clockwise, perp counterclockwise. So then expect float equal perp cw dot x will equal something. Control L, Control V, 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 V. Change this to a Y. Change this to a Y. And then let's add another C in here. C should be consistent with my casing here. So counterclockwise XZ, counterclockwise XY. So I have consistent casing here with this, and consistent casing here with this, and then that's probably gonna, yeah, okay, I think we're good. So perp CWXY, let me bring this in from the last video. Remember we swapped the two, oh look, 4 and 2, I didn't even plan that. 4, I used 4, 2 here, and we used 4, 2 here. So we swapped the 2, but negated the second one for clockwise. So this should be a 2, this should be a 4, but we're negating the second one. Oops, sorry. And then on this one, we're going to, same thing again, we're going to do 2 and 4, but we're going to negate the first one. Let's run this, be sure this is set as our startup project, run it. We should see, oh, we don't even we get build errors, we didn't even write these functions. Let's go write these functions. Vector 3dh, and then again, we're inlining a lot of this because it's short and sweet code. Vector 3D. And what did we call the function name? That's bad if I can't remember the function name. That might tell me I need to come up with a better name. Perp CWXY, it's const because we're not going to affect anything in the class. Control L, Control V, V, and then, did I do counterclockwise? Yep, counter clockwise like so. Let's grab these, go over to the inline file and actually implement them. But I want to be consistent with my placement here. So where's plus equals? It's right there. So we'll put these here. Alt, drag, delete, Alt, drag, vector 3D, D, colon, end key, const. Let's put some curlies in here. And in true test-driven development fashion, return a vector 3D object, like so, and same thing down here. Return vector 3D object like so. I'm getting the red squigglies, it makes me doubt myself, but then IntelliSense has been wrong before. Let's build and see what's saying. The left of x must have a struct. Was I not consistent here? Yeah, I wasn't. Let's put both of those there. Build succeeded, very good. Let's run this, and we get a lot of red. Loving the red. Alright, let's go implement this. So, I can't even remember. Let's bring this up again. Clockwise, we have to, well, I know I'm going to have to swap the two, so we'll just do y and x here. And we'll do a y and an x here as well. And then on the clockwise, we negate this one. And on the counterclockwise, we negate that one. Control F5, build that, run it, make sure our tests are, oh, they're looking green. I love it. We're going green. Alright, let's move on. We're getting close to detecting whether that ship's going to hit that wall or not.